A suspension bridge cable PQR hangs between the tops of two vertical towers AP and BR as shown in figure 5. A walkway AOB between the bases of the towers directly under the cable. The towers are 100 metres apart and each tower is 24 metres high. At point O, midway between the towers, the cable is 4 metres above the walkway. The points P, Q, R, A, O and B assumed to lie in the same vertical plane and AOB is assumed to be horizontal. Figure 6 shows a symmetric quadratic curve PQR used to model this cable. Given that O is at the origin, find an equation for the curve PQR. So it's a quadratic curve. So I'm going to start with just the general quadratic formula. Y equals ax squared plus bx plus c. And let's now look at some key coordinates that we know. We know that the point Q, that has x coordinate 0, because O is the origin here, and it has y coordinate 4, because we know it's 4 metres above the walkway. Point R over here, we know this has x coordinate 50 because we know the whole thing is 100 metres. It's symmetrical, so we know this is 50 metres. And we know its y coordinate is 24. Similarly, we know that point P has got x coordinate minus 50 and y coordinate 24. So substituting those into my general equation, first of all substituting 0, 4 in. So we do this in green, substitute the 4 here, a times 0 squared plus b times 0 plus c. So that's just telling me that c is 4. So let me update my equation. Now I know that y equals ax squared plus bx plus 4. Next, let's substitute in the 50, 24 coordinate. So the y coordinate is 24 when the x coordinate is 50. 50 squared is 2,500. Then we've got b times 50 plus the 4. And subtracting a 4 from both sides. Right, I can't work out what a and b are just yet, but I do have another coordinate over here to play with. So let me substitute the 24 in for the y and the minus 50 for the x. So we've got a times minus 50 squared, which is positive 2,500. Then we've got minus 50 times b, and then the plus 4. And then again, subtracting the 4 from both sides. Now, let's just compare these two simultaneous equations. If I subtract those away from one another, that's going to eliminate the a terms. So on the left-hand side, I've got 20 minus 20, which is 0. The 2,500a minus 2,500a is 0. And we've got 50b minus minus 50b, which is 100b. So 100b is equal to 0, so therefore b must be 0. And if b is 0, I can now say that 2,500a has to equal 20. So A is going to be 20 divided by 2,500. And the equation of my quadratic curve then is y equals 1 over 125 x squared plus 4. That's part A done. We are then told that Lee can safely inspect the cable up to a height of 12 metres above the walkway. A defect is reported on the cable at a location 19 metres horizontally from one of the towers. So, where that's 19. Determine whether Lee can, according to the model, whether Lee can safely inspect this defect. So remember, the model was this. And we're thinking, what's the x coordinate here? Well, we know the whole thing is 50. And it's 19 metres from the edge, so x would be 50 take away 19, which is 31. So let's think, what's the height when x is 31 according to the model? So that gives me a height of 11.688, which is less than the maximum height of 12 metres that he can inspect. So yes, Lee can inspect that defect. And then part C, give a reason why this model may not be suitable to determine whether Lee can safely inspect the defect. A whole host of different things you could mention here. You could mention things like the weather. You could talk about the cable. We've not considered the dimensions of the cable at all, like the thickness or anything like that. We could talk about we've assumed that the walkway AOB, I think it said somewhere in the question. Yeah, AOB is assumed to be horizontal. We're assuming that this is perfectly flat. It might not be. So we could say that AOB may not be completely horizontal. We also assumes that all of the points lie in the same vertical plane, which is also unlikely to be the case. So any comments along those lines will be suitable for your answer for part C.